Got on this computer. All right. So yesterday when we were doing this, we set it up as per the instructions. So we've got it set to 415 volts, and we're just going to record a data table with the voltage, current, active power, reactive power, speed, and torque. We're then going to adjust our torque control by 0.3 Newton meters up to 2.1. And then we're going to increase it by 0.1 Newton meters until the speed starts to rapidly decrease. So after we do this, what we're hoping to see is that graph that we looked at earlier with our speed versus torque. I'm going to hit that breakdown region, and then lock rotor torque is going to occur. When we do it at 415, it appears that this motor has more power than what our brake has, and we don't get that. But what we can do is we'll run the experiment, we'll look at what happens. What we can do is we can reduce the voltage, because as we know, less voltage means less torque, and then hopefully we can simulate that. So I'm just going to go ahead and do the first exercise now. For step 9. Open our data table. I'm going to clear this off. So this is what we got last time. Just going to clear it and start it again. Make sure E1, torque, line, speed. Reactive power. So 1, 2, 3, 4, 5, 6. Okay. Yes. All right. So we're going to record our first one. We're just going to go ahead and increase that by 0.3. Going to give it a couple of seconds to catch up, record. It's going to keep on doing this now until we get to 2.1. All right, cool. So now we're at the stage where we need to start going by 0.1 increments. Just keep in mind the maximum value here we can get is 3 Newton meters. So increase that to 2. Increase that to 3. Just keeping in mind, I need to give it a couple of seconds to catch up every time. It's not instantaneous. Six. Seven. 8. 2nd last one. So you can see our speed's starting to drop off a lot more. It's taking longer to stabilize at this point. Now we're going to go 3. And then this is our maximum setting that we can set it to. And as our speed's dropping off, but our torque's kind of holding stable. We were hoping at this point for our torque to drop. Maybe as the speed decreases, we might get that, but I doubt it at this stage. Decreasing energies. that. All right, so now if we look at our graph for that, what we were hoping for was something that looked like this. So kind of similar, and then about this point, we wanted that knee, and then our lock rotor torque. So we wanted a sharp cut off there, which we obviously did not get. And we can see that from our results here. It's quite constant the whole way down. It's always increasing, it never decreases. And likewise with speed, the decrease is fairly constant, although near the end we do see a slight decrease. You can see as we've left it a little bit longer, it's finally stabilized, but it's stabilized at 892.7 still. So there is a slight decrease. We'll clear all drawings. We will stop the annotation. I'll come back here. I'll record that last bit of data. So yes. Talk's still going up. No, talk's still coming up. So sorry. Here. So it does not help the case. So the way that we can do this is we've got a few options. So I'm going to go ahead, I'm going to save this and call that TT411. Save. And then I'm going to also export that as TT411. Export. What I can do is I can reduce the voltage to begin with, or at the end we can simulate it and we can reduce a little bit of the voltage here. Neither are ideal, but from what I was playing around with this morning, it worked out I need to start closer to 480 or 470, and then I can actually simulate this, and then that way the motor doesn't have more torque than the brake. So I'm going to go ahead and clear these results now. I'm going to set my brake back to 0, like so. And then I'm going to go ahead and just reduce this voltage. To about 370. And then I'm going to do these. I'll make a copy of these available in the Google Drive as well. So starting again, I'm just going to record that. I'm going to go up in 0.3 increments again. 6, 4, 9, 2, 8, 7, then we're going to go up in our 0.1 increments now. Seven. 8, and there we go. And then you can see our torque dropped off. If I go even further, I wouldn't normally suggest doing this with the motor on because you'd be burning it out, but because we're using the simulation software, it's fine. You can see we've kind of leveled out there now. So I'm going to stop that. Come back here, take this back to 0. And now when we open up our graph, you can clearly see this knee occurring. Our knee is very swept. And right here is our breakdown region, followed by our lock rotor torque. So if I get back up the instruction sheet over here, oops, apologies, and go back to the explanation, you can start to see something that looks more like this. So we've got our full load torque with that full load speed, followed by our knee. It's a long knee. And then right here, you can see our breakdown torque region followed by our lock rotor torque. So that's what we wanted to see. But to simulate that, we had to reduce the voltage. So in effect, what we've done is we've turned down our nominal speed, our nominal torque, and nominal current, thus making the motor less powerful. And therefore, when we increase this torque, this brake, it can overcome the motor. Where before our motor seemed to be too strong for the brake, so it didn't matter how much we threw at it because this stops at 3. We couldn't do that. And that's kind of what we've done. So for your lab report, I'd probably suggest showing both of these graphs. So you can discuss that in the first one in 411, with it set at 415 volts, the motor was stronger than the brake. But to simulate it, we reduced the voltage. And then by doing that, you've made the brake stronger than the motor. And therefore, you can now see the effect that we were trying to see. All right.